Okay, the next section of this section on your locus focuses on inequalities. Okay, so as the topic mentioned, the header mentioned, we're talking about the loci or points that satisfy certain inequalities. So, for example, okay, I'm going to use a numerical example to run through. You're supposed to draw this locus. Okay, sketch or shade the region indicated by this. So the trick is always draw the locus. So treat it as an equation first. So what it means is that real part of z, treat it as equal first before we talk about the inequality. So the real part of z equals to 3. So real part of z equals to 3 basically tells you is talking about this vertical straight line x equals to 3. Okay, then after you have drawn in the so-called the locus with the equal sign, then you consider the inequalities. So when is it going to be greater than or equal to 3? So what it means is that if this is x equals to 3, in order for it to be greater, it got to be to the right hand side of 3. And this is where you shade. Okay, the blue shaded region is what you're expected to shade. Okay, so next, let's go to part 2 now. So if you look at part 2, okay, inequalities, you need to shade the region. So treat it as an equal sign first. So if you treat it as an equal sign, you should realize that this is actually a perpendicular bisector. Okay, perpendicular bisector passing through -1 and 1. So you draw in the perpendicular bisector. Thereafter, you need to do your shading. Okay, so for half line, the testing is a little bit more rigorous. This is the criteria that you must satisfy. Okay, so let me just go through with you how you actually do a testing for you. So what I'm going to test is I'm going to test a point. So very conveniently, I will test 0, 1. Okay, 0 plus I. Okay, I'm going to check whether 0 plus I satisfy this inequality or not. So let's put it into the left hand side. Left hand side is z plus 1. So if I put in 0 plus I, is actually I plus 1. Modulus of I plus 1 is square root 2. Putting it into the right hand side, okay, I have I minus I, which is 0. So modulus of right hand side is 0. So you look at it now. Left hand side is root 2. Right hand side is 0. Who is bigger? Of course, left hand side. Okay, root 2. But does this result satisfy this question? Obviously, it does not. So when it does not satisfy the inequality, what it means is that this 0i is in the region that is not okay. It does not satisfy the region inequality. So if this region or this point does not satisfy the inequality, that means the other side, okay, this other side will then satisfy the inequality, and that is where you shade. So this testing method is just an example. You could test another point. So for example, you don't want to test 0 plus I. You test -1 plus 0 instead. Okay, you test -1 plus 0i instead. Okay, you run through the same test, and it should show you that this time around, the left hand side is actually smaller than your right hand side, which actually satisfy your inequality, and you shade accordingly. Okay, so before we move on any further, take note of part 1 and part 2. The inequality sign have an inclusive, okay, greater than or equal, smaller than or equal. So when you have such a situation happening, your the locus that you draw is drawn with full solid line. That means this line that you draw, okay, this line that you draw in is drawn in with full solid line. Okay, so very nicely it brings us to the third part. In part 3, you have z minus I modulus greater than 2. But this time now, there is no inclusive, it's just strictly greater. So again, running through the theory, first thing, treat it as an equation first. You realize it's actually a circle passing through 0, 1 with a radius of 2. So draw in a circle. Okay, draw in a circle. Okay, but be careful because of the inequality sign, which is greater than 2. We represent this using dotted lines. Okay, we use dotted lines now. Then this is what I'm supposed to draw. I want z minus I to be greater than 2. So this is more commonsensical. When is it larger than 2? Obviously, it's to the outside of the circle. This is where you should be shading. Okay, next one. Okay, it's a mixture already. So what you have down here, same thing, treat it as a equal sign. You should have a circle, center at 2, 0, radius 1. So this time around, have a full solid line because of the inequality sign, smaller than or equal. So draw a circle with full solid line. Then tell me when is it actually smaller than or equal to 1. The region I'm talking about is actually whole section inside here. Everything inside the circle, okay, including the circle solid line itself. So this is the first part. Second part, imaginary part of z must be greater than or equal to 0. So where is this imaginary part? Greater than or equal to 0. So obviously it is this section, okay, this section above. Okay, so going back to your inequalities concept, the magic word that links these two is the word and. So what does and tell you? And says I must take the intersection. Intersection of the green section, okay, I've shaded for you in green, as well as the red lines that I've drawn in. The intersection will just be this region, okay, that I'm shading down here. Okay, so in terms of presentation, you don't need to shade for me so many things. End of the day, you just tell me this is the region that you want. Is enough. You don't need to show me that I need to do the intersection. Presentation or answer, just shade the region required. Okay, and of course, finally, the last bit, last two example. Argument of z minus 1 plus 2i smaller than or equal to pi over 3 and pi over 4. So this one again is a half line. Okay, half line passing through 1 minus 2, making an angle of pi over 4. Non-inclusive, negative pi over 3, inclusive. So what you should have, okay, will be something like that. Okay, pi over 4 upstairs, and then pi over 3 downstairs. Okay, and where is the region you're expected to shade? Everything inside here. Okay, last one, half line passing through origin. Okay, half line passing through origin, making an angle of pi over 4 and pi over 2. So pi over 4, full solid line. Okay, this is pi over 4. And of course, this is your 90 degree. And then real part of z must be smaller than or equal to 2. Full solid line as well. Okay, vertical part, a vertical line. Where do we shade? Okay, between pi over 4 to pi over 2. And real part of z. So it's basically this entire section, okay, that we have down here.